In this video, we will be discussing perfectly competitive markets in the long run and how firms profit maximize. We're given a problem with Farmer John, who is planting yams, and he wants to know how his farm will perform in the long run. And we're assuming that farming is a perfectly competitive industry, and what we want to find is the quantity he would produce, the price he would set for his yams, the market quantity for yams, and the number of other farmers that would also produce yams. And we're given a total cost function of 80q minus 17q squared plus 3q cubed. And we're also given a demand function of quantity demanded equals 6,000 minus 15p. So the rule for profit maximization in the long run is different from the short run, as the profit maximization rule in the long run is average cost equals marginal cost, which is different from the price equals marginal cost that we saw in the short run. That still applies, but it's not used for finding the profit maximizing quantity. So what we want to do is we want to find our average cost and our marginal cost so we can set them equal to each other. So first up, we can find our average cost, which is found by taking total cost and dividing out Q. So we would have 80Q minus 17Q squared plus 3Q cubed all over Q. And so our average cost is 80 minus 17Q plus 3Q squared. Next, we want to find our marginal cost, which is found by taking the derivative of the total cost function with respect to Q. And our derivative ends up being 80 minus 34Q plus 9Q squared. Now that we know our average cost and our marginal cost, we can set them equal to each other. So our average cost was 80 minus 17Q plus 3Q squared, and that's equal to our marginal cost of 80 minus 34Q plus 9Q squared. And so right off the bat, these 80s on both sides will cancel each other out. And what we can do is we can add 34Q to both sides, as well as subtract 3Q squared to both sides. So what we're left with is 17Q equals 6Q squared. And we can divide both sides by Q. And we'll have 17 equals 6Q. And then we'll divide by 6. And we are left with a Q equals 2.83. So Farmer John would produce 2.83 yams to sell to market. So we have found our firm's quantity, or Farmer John's quantity, so our little q. Now we want to find the price of yams in the market. So we would find our price by using the profit maximization rule for short run of price equals marginal cost, and we would plug our q into our marginal cost function to find our price. So our marginal cost function was 80 minus 34 times Q, which is 2.83, plus 9 times our quantity of 2.83 squared. And by plugging that into a calculator, we get a price and a marginal cost of $55.86. In order to buy 1 yam, it would cost $55.86, so we would ultimately charge $55.86 for each yam that we produce. We cannot charge any lower because we would go below our shutdown price, and we could not go any higher as we would not be profit maximizing at that point. So next, we can find our market quantity, or our big Q, which we can find by plugging our price into our quantity demanded function. So we have big Q demand equal to 6,000 minus 15 times 55.86, which was our price. And after plugging that into a calculator, we get market quantity of 5,162.1. Next, we can find our number of firms, as the formula for number of firms is big Q, or the market quantity, over the firm's quantity, or little q, and we know both. So our big Q was 5,162.1, and our little q was 2.83, and after plugging that into a calculator, we have a number of firms of 1,824.06. So there are approximately 1,824 farmers that also grow yams. Now let's say that we wanted to also find our profit and our producer surplus. Well, remember the formula for profit being price times quantity minus total cost. And remember how we also charge a price that is equal to our marginal cost. So marginal cost is the cost to produce one more of a good, and we're setting our price equal to that. So ultimately, we're breaking even when it comes to each good sold. So going off of that, our profit is going to be 0 in the long run. And this will always be the case because perfectly competitive markets will always charge their price equal to the marginal cost in the long run. So we can assume that profit will always be 0 in any long run problem. If we were to find our producer surplus, which we recall the formula for that being profit plus fixed cost, and we know that our profit was 0, and if we look back to our total cost function, it was 80Q minus 17Q squared plus 3Q cubed, which are all variable costs with no fixed cost involved at all. So we can assume our fixed costs are also 0, which gives us a producer surplus of 0. And we can always assume our fixed cost will be 0 because in the long run, costs can change no matter the time figure. So what may be a fixed cost today may change in the future and not be a fixed cost anymore. So we can assume that fixed costs are 0 in the long run. And as a result, because both fixed cost and profit are 0 in the long run, producer surplus is always 0 too. That will conclude this video on long-run perfectly competitive markets.